Every planet in the solar system is unique in its own way. It indicates creation in some fashion.
It's almost as if God put enough variety into the solar system to just put away any natural origin theories.
There have been entire books written, even from secular people, on how unique the Earth is and how well designed it is for us to live here.
You got this billboard sitting here and you totally miss the message because you don't want to see the message. It goes back to worldview again.
Astronomy is a really powerful lesson in scale and perspective. It really shows how big God is and how ultimately small we are. If God judged us by our size, we would really be pretty insignificant.
Our universe is vast, billions of light years across. Our local neighborhood is called our solar system, but what is a solar system and why might ours be unique among all the other places in the universe?
The solar system consists of the sun and the planets and asteroids and comets and satellites that orbit the planets, basically everything that's under the gravitational influence and orbiting around the sun.
It's a flattened disk, sort of like a paper plate. The planets more or less stay in that plane as they go around and around the sun. That's our home base, and of course we're the third planet between Venus and Mars.
So there's 8 planets in the solar system. And going from the closest to the sun out to the furthest, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and then Neptune. You can break these down into 2 basic categories. The closest 4 planets are rocky, as is the Earth, made up mostly of rocky materials. So we call those terrestrial planets, after Terra, the name for Earth. And then the outer 4 planets are made primarily of gas, and in the case of the last 2, ice. So we sometimes call those gas giants, or Uranus and Neptune sometimes called ice giants because they have a lot of ices on them. The last 4 are much bigger than the inner 4. If you see them to scale, you'll see that, certainly.
Sometimes we call other planetary systems, which we've discovered the last 20 years, a number of planetary systems. Sometimes they call them solar systems, but it's not really proper to call them that because solar comes from the word sol, which is a Latin word, I believe, for the sun. So it's a proper name applying just to our solar systems.
In a broader sense, though, we can apply this to similar systems that we see with other stars. So there are elsewhere in our galaxy that we are observing where it appears that various stars have planets and presumably other things orbiting around them.
We usually call them stellar systems because other stars have planets orbiting them. Now, we didn't know that even a couple decades ago, but now we've discovered extrasolar planets out there, planets in other solar systems. Pretty remarkable. And they have their own characteristics, their own properties. We're finding that our solar system is rather unusual compared to all these other ones that we've found. They tend to have large Jupiter-type planets orbiting very close to their star, contrary to the secular expectations, by the way. And then our solar system, however, has the big Jupiter planets orbiting further away, and then the small rocky worlds orbiting close to the sun.
In many museums and places of learning, you might see a model of our solar system with the planets close together. As fun as this might be to look at, the distances and sizes of our planets in our solar system vary extensively.
Astronomers use a term called the astronomical unit, or AU, to talk about distances within the solar system. 1 AU, by definition, is the average distance between the Earth and the Sun, which is about 93 million miles. When you look at Mercury and Venus, they're less than 1 astronomical unit. Mars is a little more. By the time you get out to Jupiter, Jupiter's 5.2 astronomical units away from the Sun, 5 times the distance of the Earth. Saturn's just under 10 astronomical units. And by the time you get out to Neptune, you're at 30 astronomical units. It's 30 times farther away from the Sun than Earth is. And so you can just imagine looking back at the Sun at that distance. It would be tiny. You wouldn't hardly see a disk at all. It'd be much brighter than any other star, to be sure. And so distances are just enormous compared to the size of the planets. Often we see in textbooks illustrations of the solar system where the planets have been enhanced. They're much larger. You see the orbits and the planets together. If you can see the size of the planet, you can't see the size of its orbit. It's just that much bigger.
A really fun thing to do is to make a scale model of the solar system, and it's hard to really describe how big this system is until you try to do something like this. And you got to use really small objects because, for example, if you were to take a ball about this big to make a sun, the furthest planet away from the sun is Neptune. You would need a little pea, a little blue pea if you can find a blue one, and it would need to be about 300 yards away from your sun. So imagine the vast distances, even within our solar system, which is a very tiny portion, of course, of our galaxy, which in itself is a tiny speck among the vastness of the universe.
So it's an enormous solar system, and yet it's tiny compared to the distance between stars. A good way to illustrate the distance between stars is to jump from our model solar system. We had the sun about this big, and we had the other planets, Neptune being on the other side of campus there at the University of Colorado. The next nearest star would be about at Earth's North Pole on that scale. So it's not even in the same city, it's not even in the same continent. The distances are incredible. The next nearest star besides the sun would be the Alpha Centauri system. It's actually a 3-star system, and the closest of the 3 is called Proxima Centauri, and it's just under 4.3 light years away, with 1 light year being about 6 trillion miles. So you can multiply that out and you find it's really far away. And that's the nearest star. Our galaxy is, we think, about 80,000 light years across and contains perhaps 100 billion to 400 billion stars. So it's just incredible. The range of distances in space are absolutely amazing. Astronomy is a really powerful lesson in scale and perspective. It really shows how big God is and how ultimately small we are. If God judged us by our size, we would really be pretty insignificant.
Man has the innate desire to understand the universe that we live in. As we sent spacecraft around the solar system, we've explored each planet and found not one of them is alike.
Every planet in the solar system is unique in its own way. It indicates creation in some fashion. Now let's just go in order. Let's start with Mercury. Mercury is the smallest planet now that Pluto's been ejected as a true planet. One of the things about Mercury is it's got a strong magnetic field. And that's very interesting because magnetic fields decay naturally with time. And so if it were billions of years old, that magnetic field should be gone by now, but it isn't. It's still there and it's quite strong. In fact, my colleague Dr. Russ Humphreys actually predicted the magnetic field of Mercury, that it would be decaying, and he predicted the rate, and he was right. They sent 2 spacecraft to Mercury 30 years apart, and indeed the magnetic field has dropped in those 30 years. It's a pretty quick drop considering if it were really billions of years old, you wouldn't expect that, but it's consistent with creation. Venus, the second planet from the sun, one of the interesting things about it is it rotates backwards. And that's not something that would be expected from the standard model of solar system formation. You would really expect all the planets would be rotating the same way as they orbit around the sun, since they all allegedly form from the same collapsing cloud. But Venus is just exactly backwards, and I think God's just having fun with the secularists trying to say, explain this one. Earth, of course, is extra special in that it's designed for life. The Bible tells us that in Isaiah 45, verse 18, that God formed the earth to be inhabited. And so it's got all kinds of unique features that make it special for life, including a very large moon in proportion to the size of the planet. That is a life feature because that creates tides which keep Earth's oceans from stagnating. They have the diatoms that produce oxygen. Most of our oxygen is there. And so it's actually a life feature.
There have been entire books written, even from secular people, on how unique the Earth is and how well designed it is for us to live here. Why does it look so designed even though there wasn't a designer? I think we know the answer to that one, but they don't want to look at it that way. Even looking at it as just an ordinary planet, the Earth has some unique things on it that would cause real challenges for those who want to say it came from a cloud of gas billions of years ago. And the obvious thing from looking at it is that the Earth's surface is almost completely covered with water. I mean, 70% of our surface is water. Somebody even joked that we misnamed our planet. It shouldn't have been called Earth, it should have been called water, because we see more water here than we do dirt. Setting that aside, water is a very important component to life here. But where did the water come from? It turns out in the secular model that water could not have condensed out of that cloud here in the Earth's location. In our neighborhood, it was too warm for water to have come from the cloud. So there shouldn't be any water in the inner solar system, not out beyond Mars, as it turns out. But the Earth is covered with the stuff.
Earth also is the only planet, as far as we know, that has plate tectonics. Other planets have tectonics, but not plate tectonics. And we think that's significant because plate tectonics, we believe, were involved in the flood year. We think God used motion in the plates to trigger the flood and ultimately to end the flood as well. So the one planet where God would send a worldwide flood is the one planet that's designed to have such a thing.
There's a lot of interest in Mars because it is one of our neighboring planets in space, and it's fairly easy for us to get to as compared to some of the others. And it's also one of the ones that's most like our own. It's a terrestrial planet, it has an atmosphere, and for those who believe that life should be able to form by itself from non-living chemicals, then Mars is a candidate for that event to have happened. Now in reality that's not what we're seeing, but that's what they're looking for.
Mars is in some ways similar to the Earth. It's tilted about the same amount, so it would have seasons comparable to the Earth. It's a little further away though, so it's permanently colder than the Earth. It has polar ice caps like the Earth, and they change with the seasons a bit like the Earth's do. It has mountains, valleys, canyons, much like the Earth. It's got volcanoes, although it has no active volcanoes. But Mars has some differences as well. It's got a poisonous carbon dioxide atmosphere. It's very thin. You couldn't breathe there. It does not have a strong magnetic field like the Earth. Mars does have what's called remnant magnetism. That is an indication that Mars once had magnetism and today it doesn't. And that's something that Dr. Humphreys predicted in his model of planetary magnetic fields. It confirms the recent creation of Mars thousands of years ago, not millions or billions. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are called Jovians, meaning like Jupiter basically. They're all gas giants. People think about landing on Jupiter. You can't really land on Jupiter. It's not solid. It's a ball of gas. And at some point that probably becomes liquid as you go down in. It's a fascinating world. It weighs more than all the other planets combined. It's got more mass than all the other planets combined. And it's interesting because it confirms creation in a couple of ways. First of all, it's got a whopping big magnetic field, the most powerful of any planet. And those decay quickly. They cannot last billions of years. Also, Jupiter has a lot of internal heat. It actually gives off more radiation from the sun, more heat from the sun than it gets from the sun. And you can't do that forever. It's like a potato you take out of the microwave, it's nice and warm and it's radiating heat to space. It doesn't do that forever. Now Jupiter's a much bigger potato, it can do that for a lot longer, but it can't do it for billions of years. And so the heat and the magnetic field of Jupiter confirm its age of a few thousand years. Saturn is another interesting world. It's got that beautiful ring system, which just makes it extra special. It also has a strong magnetic field confirming its age of a few thousand years. It has a lot of excess internal heat as well, although the secularists do have an explanation, at least for Saturn, so I don't pick on them too much for that one. Other little interesting things about Saturn that just say something about the mind of God. For example, it has two moons, Janus and Epimetheus. Their orbits are so close, you'd think the two moons would collide because the distance between the orbits is less than the radius of either moon. How do they avoid collision? It's remarkable. This was a puzzle when it was first discovered. Well, it turns out as the inner moon is about to pass the outer moon's gravity pulls it and they switch orbits. And this happens every 4 years. And so the inner one catches up and they switch orbits again. It's remarkable. It's this little cosmic dance that only God could have thought of something like that. It's really remarkable. It can't be all that stable either. It's really interesting. Planet Uranus is unique in that it's the only one of the 4 big planets that does not have this excess internal heat that the other ones have. And yet it's almost identical to Neptune in every way. Neptune's the one that's farther away from the sun. You'd think it might have more internal heat, but it doesn't. And so I think that God made Uranus just to confuse the evolutionists. That's really what it comes down to. It's got a powerful magnetic field. Its magnetic field is tilted relative to the rotation axis of the planet, so the magnetic field would wobble as the planet rotates. And Uranus is tilted on its side too, which again shouldn't be from a secular perspective, where all the planets really should be spinning the same way. So in a number of ways it confirms biblical creation. Planet Neptune, very much like Uranus, it's not tilted as much, but the magnetic field is stuck in the side like a bar magnet, which goes against the secular predictions of how magnetic fields form. But it's consistent with Dr. Humphreys' predictions. Dr. Humphreys predicted the magnetic fields of Uranus and Neptune before they were measured by the Voyager spacecraft. He was right on. The secularists were way off because they were assuming those planets are billions of years old. But Humphreys calculated it based on 6,000 years worth of decay, and he was right on. So both Uranus and Neptune confirm an age of thousands of years, not millions or billions.
There are two main ideas of how our solar system formed, one naturally and the other one supernaturally. As we've explored the planets, we've found compelling evidence to support only one of these two worldviews.
Secular astronomers, for the most part, this isn't a unanimous belief among them, but the consensus today is that our solar system formed from what's called a solar nebula. And a nebula is just a big cloud of gas and dust out in space. So the idea is that 4.5 billion years ago, a little more than that perhaps, there was this big cloud of gas and dust that was spinning, and as it spun, it collapsed down into a disk shape.
We've never seen a nebula collapse. This is purely speculative.
Most of the matter falls to the center to form the sun, and then the rest of the material, what's left over, a very tiny percentage, flattens out to form a disk, and out of that disk, the planets somehow form. They form through a chain reaction. You start with small microscopic bits that start to stick together. The way that happens is not understood at all. It's just some mechanism happens.
The gas condensed into dust, then the dust particles started to stick together. Eventually they made little pebbles, and the pebbles stuck together to become rocks. The rocks stuck together to become big rocks, and the big rocks stuck together to become what are called planetesimals. Think of asteroids, same basic thing. And then the asteroids stuck together to become planets.
When they get to be a few miles across, they start attracting gravity of other things. The thing grows by accretion. And finally, in some region, here's the sun, here's a region around the sun, then this particular planetesimal grows bigger than all the rest, and it starts sucking up everything around it, so it clears out its orbit. And so you've got the inner planets that have done this: Mercury, Venus, Earth, and Mars.
In the case of the 4 outer planets, the process went further. Once you had a core of material made from the planetesimals, they were then able, through gravitational pull, to gather large envelopes of gas around themselves, which is supposed to be why Jupiter is so much bigger than the Earth, for example.
But they're made out of something different, because when the early sun began to heat up, the temperature of the sun, the heat of the sun, radiation began to evaporate out the lighter gases from the inner solar system. But beyond the asteroid belt, that material there retained all the lighter elements. And that's the reason why they're more massive and have different compositions than the rocky planets inside.
The idea is that planets like Earth probably had a hydrogen envelope, but then that was blown away from the solar radiation of the early solar system.
If you begin this way, there should be, this time, great uniformity. The planets should all be similar to each other, one would think. If they're all coming from the same dust cloud, how they would come to their distances, that's not very well spelled out.
Does this model match what we see? Well, we're told it does. I mean, the science media will tell you this is how everything got here. But really dig into the model and you'll see that it breaks down right out of the gate, really.
When you look at the planets, there are no two alike. They have different masses and different rotations and revolutions and different chemical makeup, different temperatures and densities. There's great variety. It's almost as if God put enough variety into the solar system to just put away any natural origin theories. And this is what we continue to find in this space age, just the unending variety. Every moon is different from every other one. I think it shows that God's a master artist. There's infinite change as we continue to find.
There are a number of problems with the secular view of how the solar system formed. One we've already mentioned: gas clouds don't want to collapse on their own. Their own gas pressure tends to resist that. Two other problems, though, in terms of getting a cloud to collapse. One is that the angular momentum. As you've probably seen a skater, as she pulls her arms in and she spins up like that. Well, a gas cloud would do the same thing. As it gets smaller and smaller, it would tend to resist getting smaller, because the angular momentum, the spinniness of it, would tend to prevent any further collapse. Also, magnetic fields. Nebulae have trace magnetic fields, very small, very weak magnetic fields, but as you collapse that nebula, it strengthens the magnetic field. And just like pushing two north ends of a magnet together, it resists any further collapse, so a nebula would tend to be prevented from collapsing because of the magnetic pressure. Even if you ignore all of that, you've got the planets. How do you make a planet? Well, there's some problems with that. The idea is that the terrestrial planets formed by dust grains sticking together, but they've found that they haven't been able to work out any details by which those dust grains could stick together, and that's a standing problem in the secular view of solar system formation. So those are just a handful of the difficulties It make me think that it's not possible for a solar system to form just by the natural laws of physics. So that lends itself naturally to a creationist interpretation of the solar system where God made it by the word of his power, not by the standard way that he maintains the universe today.
From Mercury and Venus closest to the Sun to Neptune, 30 astronomical units away, it's incredible that our Sun is able to keep the planets orbiting. But how does it work? Why don't the planets eventually fly away?
One of the interesting problems that Isaac Newton actually solved. What is it that causes planets to have their orbits to have the shapes that they do? And Isaac Newton realized that it was the sun's gravity that planets fall around the sun.
The sun sitting here, it has a tremendous gravity because it has more mass than anybody else does. You got a planet sitting here, and there's a force of gravity between them. The planet also possesses angular momentum, which causes it to move forward. And as it moves around, it's pulled in all the time towards the center. Sometimes people misunderstand this. They think there's some sort of special balancing act. There's nothing really balancing required. If you have a rock on a string, you can put it over your head and whirl it around like this and keep it a pretty constant motion. What you're doing is you're providing a force between your hand and the distant rock by a tension in the string, and that tension is providing what we call centripetal acceleration to keep it going around. As long as the string breaks and you can't break gravity, the thing can go on indefinitely without any maintenance. Anytime you have orbital motion like this, you require centripetal acceleration to do that.
If you take a baseball and you throw it far enough, it would actually, the Earth would curve down beneath it, and so that's what an orbit is. It's an object falling around another object.
Now, we don't understand gravity, but it's the attractive force between us and the Earth, holds us on the ground, also keeps all the planets from escaping. So it's the sun's gravity that keeps things in orbit along with everything else in the solar system.
Even at far distances, Neptune is still affected by gravitational pull from the sun. Gravity falls off with distance. It gets weaker, but it doesn't really decrease to zero. You'll eventually get far away to where it's an insignificant force, but strictly speaking, its effect is, can extend for a long ways. So even as far away as Neptune is, it's still in orbit around the sun because the sun's gravity holds it there.
People had suspected perhaps that gravity might be the cause of that. They knew there was some kind of magnetic force, and Isaac Newton worked out the details of that.
He figured those out, figured out the quantities of pull, and found out that it diminished as inversely as the square of the distance between the objects.
Now, Isaac Newton did not think of gravity as a replacement for God's power. He thought of it as an example of God's power, and I fully agree with him. Gravity is the name we give to the way that God causes the planets to orbit the sun.
The next step in the problem was made by Einstein. He figured out properly, I think, that the fabric of space itself gets dented by the presence of mass. I haven't published anything on this, but I think it's because the fabric of space itself is accelerating.
If naturalism were true, then we should find certain characteristics around the solar system which indicate that it's billions of years old. But as we examine each planet, it becomes apparent this is just not the case.
You can look at the other objects in the solar system. We have all four of the large planets. The Jovian planets have ring systems. They appear to be very young systems. They could only exist for a few millions of years maximum, not billions of years. And yet all four ring systems are there, indicating that they're extremely young. We have two planets that rotate backwards. They spin on their axes in the backward direction. Everything else goes counterclockwise as viewed from above the Earth's north pole. All the planets orbit the sun in that direction as well. And these two planets go backwards, and it's usually attributed to a late hit, that they were forming, something big came in and went the other way to de-spin it. Now, when something big hits the planet, it would cause the orbit to be affected as well. And you would expect the orbit to be more elliptical, taking such a big late hit. But the two planets that do that, Venus and Uranus, have the most circular orbits. They're more circular than our own orbit is around the sun. And so the orbits, if you're looking at an evolutionary sense, long periods of time, chance, the sort of thing, the Venus and Uranus, their orbits bespeak of no big hits, but their rotations do.
As an example, we can look to the planet Saturn. I mean, we're familiar with Saturn, and it's famous for its beautiful rings. Those rings are also very bright, and it turns out that if Saturn's rings were actually 4.5 billion years old, they wouldn't be bright anymore, because they would darken as time passed. As Saturn moves through space, it would gather dust and other material that would darken the rings over time. The rings aren't dark though, they're still bright. So the secular astronomers are scratching their heads, how can they be billions of years old and still so bright? The planet also has several moons that are interesting for the age discussion. One of Saturn's moons is called Enceladus. And a few years ago it was discovered that Enceladus has geysers of water and ice coming out of its south pole. Now this is completely unexpected because Enceladus is supposed to be 4.5 billion years old. It's a tiny little moon, it's not big. It should have cooled off from its formation a long, long time ago. It shouldn't have the energy to be geologically active anymore, but it is still geologically active. It doesn't look billions of years old after all. Now that's sort of a vague thing, doesn't look billions of years. We can get more specific with one of Saturn's other moons called Titan. As you can gather from the name, Titan is a very big moon. It's actually bigger than the planet Mercury. Titan has an atmosphere, which is interesting because part of the components of that atmosphere is methane. And methane gets broken down by sunlight into ethane and other chemicals. It turns out that you can model this moon and show that all the methane would be gone from the atmosphere in just 10 million years. But the moon's supposed to be 4.5 billion years old. That's 4,500 million years, as opposed to 10 million years where all the methane would be gone. The secular scientist said, no problem. There must be some source of methane on Titan's surface that would keep replenishing the atmosphere over these billions of years. Not only that, but there also must be 4.5 billion years worth of ethane built up from all the methane that was broken down over all this time. So before we got to Titan, they were predicting that there would be a global ocean of methane and ethane on Titan, and it would be liquid because it's very cold on Titan, so methane and ethane would both be liquid. So there are predictions of deep global ocean on Titan before we got there and actually looked. The reason we had to go there is because the atmosphere is opaque, we can't see through it from here. So we actually had to go there, a probe down through the clouds. When the clouds were penetrated and we saw the surface, no global ocean. There's what appear to be a few lakes at the poles, but the rest of the surface, there's no methane, there's no ethane. Everything that was predicted is not there. Titan does not look 4.5 billion years old. It looks very young. There's other age indicators we could talk about, but there's a lot of things within the solar system that do not match the 4.5 billion year old model that everybody tells us we know is true.
And I sometimes think, well, the Lord just made that to confound us. You got this billboard sitting here and you totally missed the message because you don't want to see the message. It goes back to worldview again. If you've excluded any consideration of God or any kind of message He might send you, then of course you're going to ignore that, your filter.
The Bible presents the fact that our home planet was our Creator's focal point of life in the universe. Yet Hollywood films and fiction literature fantasize about finding Earth-like planets outside our solar system. Their base assumption is that our Earth isn't so unique.
We've discovered hundreds of solar systems around other stars, but none of them are like ours. And what's interesting is the whole point of looking for other planetary systems has been predicated upon the idea of evolution. You want to find, first of all, planets around other stars to prove that they're common, and then find a bunch of planets that are like the Earth. And once you find Earth-like planets, then maybe the possibility of life. Have we found that? Well, we haven't. No. First of all, the planetary systems we find are kind of weird. In our own solar system, the big planets are very far away from the sun. In these systems, the big planets are close by. Then they have to have the special pleading of all sorts of planets switching off energies and switching orbits. It's crazy stuff. We haven't found anything remotely resembling our planetary system yet. We've not found any of these planets that even remotely resemble the Earth. I have to read every couple times a year about some Earth-like planet, and I start reading, I have to laugh because it's nothing like the Earth. Some creationists are worried about other planets around other stars, as if this is going to threaten our worldview. I welcome it. My prediction from a creationary viewpoint would be we might find planets around other stars, we might not, I can't say. But I will predict this, we won't find life living on any of these other planets because we're made here specially. That's the only where life can come about. What we've found so far bears that out. All this work for looking at planets around other stars is confirming what I would expect from the creation model, but the evolutionists have been surprised every time. They've had a theory for a long time about how our solar system formed, and they've had to completely rewrite the whole thing because of the reality of these other systems.
For many years, amateur astronomers and astrologers have warned of some great catastrophe taking place when our planets align. Is this something to be worried about?
This idea of the lineup of the planets, it just seems to surface every few years. Now, if you could go way back to 1980, there was a popular book called The Jupiter Effect, a bestseller. And this writer said the planets are going to line up. Jupiter's the biggest planet, so it dominates. And it was going to pull the Earth out of shape and trigger the earthquakes and cause the tribulation. It was the end of the world.
All the astronomers and the physicists were saying, no, the forces are way too small. And people were saying, well, maybe all you need is a little tiny force to upset some balance somewhere on the Earth and trigger an earthquake. Well, nothing happened.
In my adult lifetime, I've been to about 4 of these. We had one in '79, one in '82, we had one in the late '90s, another one around 2003. We had the famous Mayan calendar debacle in December of 2012, and I kept telling people that, 2011, I said, well, I'm just worried about getting out 2011 because my Dilbert desk calendar has nothing after December 31st.
The fact is the planets do align themselves on a fairly regular basis, and nothing catastrophic happens.
They can more or less gather in the same portion of the sky now and then. It's not all that unusual, a conjunction of planets. I've never seen a calculation of when they would all line up in a straight line for an instant as they're traveling around the sun. I'm sure it's a trillion-year time scale. I don't believe it's happened since creation and won't happen till the end of this age. The planets are far enough away from us that we don't experience any gravity effects from them.
The gravitational pull of the planets is tiny, especially compared to the moon. The moon has a much greater gravitational influence, and it's enough to cause tides on the Earth, and the sun has an effect as well. The next biggest effect would be Jupiter, and we line up with Jupiter every year. There's no increased catastrophe or things like that, and so these sort of doomsday scenarios just really aren't realistic when you understand the physics of the situation.
So even if the planets would line up, the story is an urban legend that the Earth would be destroyed. It wouldn't happen. God didn't plan this whole solar system that some kind of event like that is going to crash the whole place. He's got other plans.
People are trying to look for physical mechanisms to verify and prove that the Bible's right. But I think end times are going to be unique. The world's going to end catastrophically. The heavens are going to pass away with a great noise and be a new heaven and a new earth. I don't think there's a naturalistic, scientific, physical explanation for it. It's miraculous. And I think when the Lord wants to make a third of the stars dim, and the sun to dim, the moon turn to blood, it's going to be such a miraculous thing. If your heart and mind are open, you're going to see it for what it is. Now, of course, if you're part of that delusion that God sends because of your unbelief, you're going to find out a perfectly good explanation as to why it is not the end of the world and God isn't intervening. It all depends on your worldview again, once it doesn't it.
As we explore our solar system and the universe, one thing becomes very clear. The Earth is uniquely suited to sustain life. The evidence is overwhelming. We were put here on this planet on purpose.
We look at the solar system, we're not the center of it. Of course, that's the sun, and we are the third planet, but I think that's right where we belong. It's kind of an old story that we're in the right place, and it's true. If you go a little bit closer to the sun, you run into the planet Venus, which has a runaway greenhouse effect and a temperature of about 900 degrees Fahrenheit all day, all night, all year. It never changes, it just cooks. If you move further out from the sun than the Earth, then you hit the planet Mars. Mars is interesting. It's about half the size of our planet. Has a similar tilt, and its temperatures vary somewhat, but because it is further from the sun, the average temperature is below 0 when it comes to Fahrenheit, so it's cold, frozen place. So if you go closer to the sun, hot. Further from the sun, it's cold. I believe that the Earth is in just the right place where we have water in its 3 states, liquid, solid, gases. We certainly have a kind of an atmosphere that we need to breathe. Yes, the Earth is well chosen where we are placed.
Earth is in a region of the solar system that's called the habitable zone, or more colorfully, the Goldilocks zone. It's not too hot, it's not too cold, it's just right. And that's what we'd expect given the creationist worldview.
But being in the right place isn't good enough. The moon is quite dead and it's in the right place. You need the right amount of mass, you need the right composition to hold on to the right kind of atmosphere, you need liquid water, you need a long list of things that a planet needs. And the Earth has all of those brought together.
Some critics have looked at this and said, if there was a creator, he didn't do it right, because we need oxygen and the majority of our atmosphere is nitrogen, 78%. What if the Earth had 78% oxygen? You better not make a spark. There better not be any lightning, because oxygen, you know, it's an oxidizer. It helps the things burn and spontaneous fires would break out. But that's, I think, the exciting thing about the creation viewpoint. There are reasons and plans and purposes for everything, including even the minor components of the air, and those are being researched.
The two worldviews offer a very different end to our solar system. One seems quite bleak, while the other offers great hope for those who follow the Creator.
The secular worldview is that the solar system will go on for quite some time, over long periods of time. There's some chaos that can come in. I'm talking about over millions and billions of years. The planetary orbits will change. Their own Earth's orbit changes a little bit. It gets more elliptical, less elliptical. It swings around, it gets bigger, it gets smaller. These are perturbations, little gravitational tugs that do this. There's no grand thing that you can foresee that would cause a problem.
The sun, they say, will eventually run out of its hydrogen fuel, at least in the core, and they say it'll swell up to become a red giant star. And at that point, it will envelop the inner planets, Mercury, Venus, and probably the Earth. It would strip away Earth's atmosphere before that happened, and so it would be a rather bleak future for all of us. Fortunately, they say this won't happen for another 5 billion years or so, but nonetheless, the death of the Earth is assured. Now, the Bible paints a very different picture. It does talk about a fire, but it's a purifying fire, one that burns away everything that is displeasing to God, and a new heavens and a new earth wherein dwelleth righteousness forever. In the biblical view, Earth is purified and the new Earth lasts forever. I don't know how God's going to do that in terms of the physics of it, but we can trust in His Word that that will come to pass. And so the future of the solar system is very different in the creation point of view.
As we study the solar system, we see God's signature all over His creation. It tells us about His ingenuity and creativity.
When I look at the solar system, I see God's handiwork. The order and regularity of the planets moving around the sun was actually, you could argue, the foundation for physics itself, because Kepler worked out the laws of orbital motion and then Isaac Newton built on that and when he essentially invented physics. The majesty and beauty of the planets like Jupiter and Saturn and others, the beauty of Earth as we see it from space, and then contrast that with some of the other planets, which gives us a perspective on what could have been.
I think the solar system certainly displays God's creativity, each of the planets having its own unique properties.
The surface of Venus, for example, it's over 900 degrees Fahrenheit there. It's hot enough to melt lead. There's 90 atmospheres of pressure. I mean, you would be crushed were you to try to step out of a spacecraft there. Mars, even as similar as it is to Earth, is still a very bleak, desolate place. Beautiful in its own way, but still desolate. Contrast that with the lushness of the Earth that we live on. I think we see God's handiwork here in creating for us a beautiful place for us to live. And that shouldn't surprise us as Christians because the Bible says that He created a wonderful place for us to live, as it says in the book of Isaiah.
One thing the universe does exhibit is God's diverse creativity. We see that all over the place, God creating each of these different worlds according to His creative design. I always think of that, especially when I look at Saturn, because of its uniqueness. God just put, rings around this planet, and who would have thought of that? I mean, that was wild. That was a problem in astronomy back when it was first discovered. In the 1600s, people didn't know what those rings were. They couldn't see them very clearly. Galileo's telescope was tiny compared to telescopes today. He could tell there was something to the side of Saturn, but he didn't know what it was. What a ring system. What a brilliant idea, having trillions of tiny little moonlets orbiting around the planet's equator. I think that demonstrates God's creative diversity. All of the planets do, each of them in their own way. Venus rotating backwards, Mars having 2 moons and polar ice caps. It's just incredible.
As we grow in our scientific knowledge, it becomes clear our solar system was designed, especially planet Earth. This knowledge should give us motivation to seek out our loving Creator and give Him glory. For surely the heavens declare the glory of God.